if y equals, oh my word, x squared plus 3x plus 1 all multiplied by 2x cubed plus 5x squared plus 9x plus 2, then what is the slope of y when x equals 4? Oh my goodness, what kind of sick, twisted, evil mind comes up with questions like this? Oh right, someone who likes maths. Okay, so we want to know the slope of y when x equals 4. Well, one way to do it, and we can use just the tools that we've already got, is to expand out these brackets, and then we can take the derivative of each term separately, and then we can plug x equals 4 in, and that'll give us the slope. But that's an intimidatingly large amount of hard work. It's not difficult, it's just laborious and time consuming. So we could use a nice little trick called the product rule. And the product rule basically says that if you've got two functions, let's call them f of x and g of x, and I want to differentiate the whole lot with respect to x. Again, I'm mixing up my terms, but that's perfectly allowed. Then an easy way to do it is to take the derivative of f of x and multiply it by g of x, and then add to that the normal f of x that's not taken the derivative of, multiplied by the derivative of g of x. In other words, that's f prime of x times g of x plus f of x times g prime of x. So you take the one thing that you, well, let's just do it and then it'll become obvious. Okay, I'm going to move this out of the way. There we go. Right, so we can take this part and we can just write it down. So that's x squared plus 3x plus 1. And then we can differentiate this part. So that's 3 times 2 is 6, so that's 6x, and cubed becomes squared, plus 2 times 5 is 10, and that x squared becomes x, and then plus 9, and the constant becomes 0, so that we can ignore that. And then we add the derivative of the first lot, which is, so I'll go back to explaining that it's this one. So now this time we're taking the derivative of this part, so that's 2x plus 3 multiplied by where's my cursor gone? Multiplied by this part. So that's 2x cubed plus 5x squared plus 9x plus 2. let's just move that. There we go. And of course we can say that this is dy by dx. And that's it. That is the derivative. So now if we want to get our 4, we want to know what the slope is at x equals 4, we can just plug the number in. So that's 4 squared plus 3 times 4 plus 1 into 6 times 4 squared plus 10 times 4, mixing my notations again, plus 9 plus 2 times 4 plus 3 half the job here is finding my cursor. Okay, and then that's into 2 times 4 cubed plus 5 times 4 squared plus 9 times 4 plus 2. Okay, let's simplify that. So 4 squared is 16 plus 3 times 4 is 12 plus 1, that's going to be 13, so that's just 16 plus 13, which is 29. Uh, 6 times 16, oh my goodness. Do you know what? I'm not even going to try, it's going to take too long. I'm going to get a calculator. Alright, so that's 6 times 4 squared plus 10 times 4 is 40 plus 9. So that's 145 plus, this was a stupid question. Okay, so there's 8 plus 3 is 11. Two times 4 cubed which is 64 times 2 is 128 plus 5 times 16 plus 9 times 4 plus 2. That's 246, which is equal to 29 times 145 plus 11 times 246. 6,911. I'm glad I didn't try to do that in my head. 6,911. Wow. Okay, that was a stupid question to ask, got to say. That was not smart as an example, but it does go to demonstrate that we can use the product rule to make it a lot easier to differentiate rather complicated multiplications. So when you see the product rule, sometimes it is easier to just algebraically multiply it out and then find the derivative of each term, but sometimes it's easier to just use the product rule because multiplying everything out would just take too long because there's so many different terms involved. So that's the product rule. The derivative times the function plus the function times the derivative when you've got two different functions multiplied by each other. Okay, let's look at another trick for making differentiation a bit easier. And this time, actually, I'm going to leave the product rule where it is. And this time, let's look at a different question. Let's consider y equals, let's say, 3x squared. I'm just making this up off the top of my head. Plus, let's say, 5x plus, why can't I write? Oh yeah, I didn't pay attention at school when I was doing my handwriting lessons. Plus 8. And all that is divided by 7x plus 6. How's that? It's just total random numbers there. Okay. So now we're trying to divide two functions practically. So that's similar to with the product rule, but this time we're going to call it the quotient rule because when you have one thing divided by another, the result is called a quotient. So now this time I just want to find dy by dx. I'm not going to bother with the slope at some point because anybody can just shove the numbers in. So let's find dy by dx of this monstrosity. Okay, so this time that we use the quotient rule. I mean, we could try to simplify it algebraically if indeed it can be simplified, which something tells me it probably can't. So we are going to want to use the quotient rule. So let's do d of f of x over g of x with respect to x is equal to, so this time it's f prime of x times g of x minus f of x g prime of x So does that look familiar? It looks very much like the product rule above, except the plus has been turned to a minus. But now the big difference is all of this is divided by g of x squared. Let me make that a bit clearer. There we go. Okay, so this is our quotient rule. So let's go ahead and try to find the derivative of this. And I'm going to give myself a load more space. Okay, so what we have is, let's call 3x squared plus 5x plus 8 f of x and 7x plus 6 g of x. So let's say f of x equals, and g of x is equal to, and then you can get rid of this. Right. So I want f prime of x. Actually, what I want is to find my cursor. Okay, so 2 times 3 is 6, so that's 6x. The 6x squared becomes 6x, or the x squared term becomes an x term. Where did my cursor go? Here we go. Plus, and then 5x becomes 5. So 3x squared plus 5x plus 8, the derivative of course is just 6x plus 5. And then that is multiplied by g of x. So we just copy that, so that's 7x plus 6. And then we subtract f of x in its entirety, so that's 3x squared plus 5x plus 8, and then that has to be multiplied by the derivative of g of x. Well, the derivative of 7x plus 6 is just 7. And then the whole thing is divided by g of x squared, so that's 7x plus 6 squared. And if you want to know the slope at any particular point, you just plug your numbers in. Just plug the value for x in and that'll give you your slope. And that's it for the quotient rule. In fact, let's just tidy this up a little bit. I want to put the quotient rule just up here, out the way. And then I'm going to delete this. Now, those were relatively straightforward. Let's see if I can come up with a nice difficult one again. Let's say y is equal to 3x plus 1 all squared. All you need to do is take 3x plus 1 multiplied by 3x plus 1 and use the product rule. Okay, that's not so hard. Okay, so what if I say raised to the power negative 2? Well, okay, then you just take 3x plus 1, or rather you take 1 divided by 3x plus 1 times 3x plus 1, and you can use a combination of the product rule and the quotient rule, and that will again give you the derivative. So again, that's a little bit too easy. Okay, let's make it harder. Let's say, what about if y equals the square root of 3x plus 1? Now that's a bit more difficult. Okay, so in this case we're going to want a new rule called the chain rule. And the chain rule is very important because later on we're going to look at implicit differentiation, and implicit differentiation relies heavily on the chain rule. In fact, it falls naturally from the chain rule. Okay, so if what we can do with this is to rearrange this, so y equals the square root of 3x plus 1 can be rearranged to look like this. Because the square root of something is that thing raised to the power of 1/2. There we go. And that makes it more easy to use a chain rule. Okay, so what's the chain rule? Where did my cursor go? Here, cursor, cursor, cursor. Oh, it's right down there in the very corner of the screen. Okay, so the chain rule says that if f of x is equal to g of h of x. So remember we covered nested functions earlier. Then f prime of x would be equal to g prime of h of x multiplied by h prime of x. Okay, looks complicated? I agree. That's why I think we should scrap it and not bother with it. I prefer to think of the chain rule as the dy by dx is equal to dy by du times du by dx. And that I think is beautiful and elegant, because if you think of it in terms of fractions, you could just think, oh, cancel, cancel, and you've got dy by dx. And so it intuitively looks right, and it intuitively looks, you can just see by looking at it how it works. So that's the chain rule I'm going to be going with. So I'm going to say dy by dx is equal to dy by du times du by dx. Now, how do we use this? So again, we need to rearrange what we've got here. So I'm going to say let u equal 3x plus 1. So now y becomes u raised to the power 1/2. And now we can just use the chain rule. So dy by dx is equal to, well, dy by du, where y is u to the power 1/2, so that's 1/2 times u raised to the power of 1/2 minus 1, and 1/2 minus 1 is negative 1/2. And then this has to be multiplied by du by dx, so that's derivative of 3x plus 1, which is just 3. So now 3 times 1/2 is 3/2, so let's just write dy by dx is equal to 3 over 2 times u, which is 3x plus 1, and that's raised to the power negative 1/2. And that is all there is to it to get the derivative using the chain rule. Okay, so I'm not going to highlight the answer, I'm going to highlight our three rules. So that's the chain rule, the quotient rule, and the product rule. And with these three rules combined with the derivatives of the trigonometric, logarithmic and exponential functions that we covered in the last lesson, and the polynomial derivatives that we covered just before that, you should now be fully equipped to handle most forms of differential calculus. That's just a fancy way of saying find the derivatives or find the slope of a curve at any given point. I'll leave you with a question and then we'll pick up in the next lesson, where I think we should cover, what were we going to cover next? Implicit differentiation, which falls naturally out of the chain rule, which we've just covered. So I think in the next lesson we'll probably cover implicit differentiation, and that just might finish us off with differential calculus. Okay, so I hope you enjoyed that, and I'll look forward to seeing you in the next lesson.